Greetings everyone, I'm Adam Haritan. Welcome to the beautiful woods of western Pennsylvania. I have a question for you. When you look at this ecosystem, the one I'm standing in right now, can you imagine what this might have looked like 400 years ago? Now, I'm not giving you much context other than visuals of what this ecosystem currently looks like, but I'm wondering if you can try to picture how this all might have looked in the early 1600s. Do you think it looked relatively the same back then as it does today? Or do you think it looked different? Now, I might be biased, but I think these are really good questions to ask. And I think they're really good questions to ask because when we ask these kinds of questions and wonder about these kinds of things, we begin to intentionally pay attention to what's around us, and our awareness grows. When our awareness grows, our ability to read the landscape improves, and our connection to places that look like this deepens. And these are all things, I think, that human beings in the 21st century in this part of the world desperately need. In awareness of the land, in ability to read the land objectively, and a deeper connection to the land. 400 years ago, there was most likely a forest in the same exact spot I'm standing in right now. But was that forest similar to the forest that's here today? And more generally speaking, throughout the entire northeastern United States, from Maine to Pennsylvania, are today's forests similar to the forests that were here 4 centuries ago? Well, as it turns out, we actually don't have to wonder too hard about the answer because researchers have been trying to figure this all out for a long time. And what researchers have uncovered is actually kind of surprising and paradoxical. After 400 years of human land use, the northeastern forest is simultaneously largely unchanged and completely transformed. How can that be? Especially considering the fact that so much has happened here in the northeastern United States in the past 400 years. How can all of this be largely unchanged and completely transformed? Well, to get some answers, we first have to understand something about the kinds of changes that have taken place in this part of the world. Forests covered a large portion of what is now the northeastern United States at the time of European settlement. Many of these forests were what modern ecologists would call late successional old growth forests, with big old trees and lots of structural complexity. But not all of these forests were dense, dark, closed-canopied ecosystems. Some of them were actually very open and more like woodlands and savannas. And they were like this because indigenous people burned a lot of land, particularly along the coastal and southern areas of the northeastern United States, where fire-adapted oaks, pines, and hickories dominated. But wetlands, grasslands, barrens, and other open ecosystems were common too, leading to a patchy mosaic of different kinds of ecosystems in this region at the time of European settlement. Now, things certainly changed with the arrival of Europeans. Initially, colonists cleared small areas for homes, fuelwood, and subsistence farming. But as populations grew, this modest clearing accelerated into large-scale deforestation driven by the demand for cropland, pasture, timber, and fuel. Much of the region was transformed into fields and pastures, and by the mid-1800s, less than 30% of the original forest remained in many parts of the Northeast. Now, interestingly, this trend reversed pretty sharply after the Civil War and into the 1900s when westward migration led to widespread farm abandonment in the Northeast. This initiated a century of reforestation, transforming the Northeast from a largely agricultural landscape into one of the most heavily forested regions in the country today. Which leads us back to our original question. How similar are today's forests, the ones that came back after extensive deforestation and agricultural clearing, to the forests that existed 4 centuries ago before significant land use changes took place? Well, the authors of this paper wondered the same thing, and they made some pretty important findings by taking an interesting approach. They analyzed witness trees and compared them to trees that exist today in the same areas. If you're unfamiliar with witness trees, these were specific trees marked or recorded by colonial land surveyors to define property boundaries and corners during land grants. Surveyors wrote down sometimes the genus, sometimes the species, and because the trees were typically chosen before forests were heavily altered, they provide one of the best sources for reconstructing what northeastern forests looked like before extensive deforestation took place. So what did the witness trees tell us? What did the broad northeastern forest look like 4 centuries ago? And how does this all compare to what it looks like today? Well, I mentioned that the northeastern forest today is both largely unchanged and completely transformed. It's unchanged in the sense that pretty much all major tree species, for the most part, are still here. So if you only looked at a list of tree species in the Northeast, you'd get the impression that the northeastern forests haven't really changed all that much in the past 4 centuries, even though there have been plenty of opportunities for some species to disappear and others to move in. But this apparent stability in which trees are still present conceals a much deeper transformation. The relative abundance and distribution of these species have shifted, and the overall quality and character of the forests have changed. A major finding by researchers is that there's been a broad ecological shift away from long-lived, slow-growing, late successional trees to faster-growing, more light-demanding, early to mid-successional trees. In the past 400 years in northeastern forests, American beech, a classic late successional tree, has experienced the largest decline in relative abundance from the pre-colonial to modern era, dropping from 22% to 6.5%. Eastern hemlock, region-wide, declined from nearly 11% to 7.5%. Oaks declined from 17.5% to a little over 11%. Now, because these are region-wide statistics, we might assume that declines have happened everywhere, but that's not necessarily true. When we look at this map of relative change in oak abundance, we see lots of browns in the southern and coastal areas of the Northeast, and this tells us that a negative change in relative abundance in these areas has occurred over the past 400 years. But farther north and inland, oaks have actually increased in relative abundance. In the case of American beech, despite region-wide declines, its relative abundance has remained fairly stable in the Adirondack Mountains of New York and has even increased in other localized areas. But what a lot of researchers are discovering is that in areas where beech is increasing, it's not increasing as a dominant canopy tree, but as an understory and mid-story tree. If you walk through a lot of northeastern forests, you often see dense thickets of small-stemmed American beech, and a lot of this has to do with disease. When large beech trees succumb to something like beech bark disease, the trees often respond by sending up numerous root sprouts that actually reduce the biodiversity of a forest. Now, you might be wondering, with a region-wide decline of beech, hemlock, and oaks over the past 400 years, what trees have taken their place? Well, if you've been spending a lot of time in forests in this part of the world, you shouldn't be too surprised to hear that there's one group of trees whose abundance has increased quite significantly, certainly in the past 400 years, but really in the past 50 to 100 years. Do you know what group of trees that is? Well, it's the group of trees that this species belongs to. This group of trees is the maple genus. One of the biggest findings from this study was that maple had by far the largest absolute change in relative abundance over the past 400 years, from a little over 11% to nearly 31%. If you look at this map, you see all the greens and blues associated with a positive change in relative maple abundance, and you see this all throughout the region. And a lot of this has to do specifically with the rise in red maple abundance. Prior to European settlement, red maple was a relatively minor component of the northeastern forest, growing mostly in wetland and bottomland ecosystems. Today, the tree is found in all kinds of ecosystems, and one major factor behind this has to do with the suppression of fire and lack of intentional burns. Red maple is a fire-sensitive tree that does very well when fire is removed from the landscape. Cherries have also increased in relative abundance pretty significantly, from 0.4% to 4.4%. And a lot of this has to do with an increase specifically in black cherry abundance. Like red maple, black cherry is a fire-sensitive tree that does very well in early to mid-successional habitats. Black cherry has experienced some regeneration problems in the past few decades, but its numbers are still much higher today than they were prior to European settlement. When we consider the rise in both red maple and black cherry abundance in northeastern forests, particularly in areas that were once dominated by oaks and pines, we see this process of mesophication taking place. Mesophication is the ecological process where a forest gradually shifts from being dominated by fire-adapted species like oaks and pines to fire-sensitive species like maples and cherries. And according to ecologists, mesophication is associated with wetter leaf litter, cooler conditions, and also an increase in tick abundance. So if you're wondering why you're seeing lots of ticks today, part of the reason might have something to do with mesophication. Now perhaps you're wondering about this tree species right here. Do you know what tree this is? Well, this is American chestnut. I mentioned that for the most part, all major tree species that existed in pre-colonial northeastern forests are still here today, despite large-scale logging, agriculture, and development. Well, another major factor significantly influenced eastern forests in the 20th century and nearly eliminated a single species. That factor was and still is chestnut blight. Chestnut blight is a fungal disease that was first detected in the United States in the early 1900s, and within a few decades, nearly every large American chestnut tree in this part of the world was either killed by chestnut blight or by people who tried to stop the spread of the disease by cutting down healthy chestnuts. Today, American chestnut is mostly absent from northeastern forests as a large canopy tree, but it still exists in many areas as a smaller tree. But an interesting point made by researchers, and this is something that contradicts what a lot of people currently believe, is that prior to European settlement, American chestnut wasn't an incredibly abundant tree in the northeastern forest biome. According to researchers, the historical dominance of chestnut is currently often overstated. The average relative abundance of chestnut in the pre-colonial data was only 3.3%. Its highest abundance was in the Appalachian ecoregion, and even there it was less than 10% and just 1/4 that of oak. Of course, this isn't to say that American chestnut wasn't an important species for humans and for wildlife, or that its loss wasn't a big deal. It certainly was, but on a region-wide scale, the relative abundance of American chestnut in pre-colonial northeastern forests wasn't as high as many people think it was. Finally, it's important to say something about the quality of today's forests and how this all compares to the quality of the forests that were here centuries ago. Very few forests in the northeastern United States survived the onslaught of logging and agriculture. And some estimates suggest that less than 1% of these so-called original forests are still here. Now, the northeastern United States today is a largely forested region, but these modern forests are very different than the forests that were here centuries ago. Most modern forests are what we would call second growth forests, with trees that are typically under 100 years of age. The structure and ecological processes within these forests are different. The sizes of these trees are relatively smaller, and there's typically less diversity in these modern forests compared to what we might expect to find in many pre-colonial forests in the northeastern United States. But here's the interesting thing. Even the old growth forests that exist today are different than those that were here in the 1600s. Over the past few centuries, animal browsing activity has changed these forests. Human activity has changed these forests. Fire regimes have been altered. Some animals have been extirpated or have gone extinct. And the introduction of non-native species has altered the structure, composition, and function of old growth forests. Despite these changes, and despite the fact that forested ecosystems in the Northeast continue to be broken up and fragmented, there's no denying that forests are still here. And because all major tree species, for the most part, are still here, we can at least appreciate the incredible resilience of the northeastern forest biome over the past 400 years in the face of seemingly insurmountable obstacles. I don't know about you, but for me, it means a lot to know just how resilient the landscape can be. And this is why I encourage you to interact with a piece of land not only by simply walking through it or just by memorizing the names of certain organisms, but by studying its history. When we study the history of a landscape, when we learn its ecology, when we learn its geology and try to make sense of things, we start to see how all the pieces fit together, and we see how we as human beings belong. And this is not a small thing. A lot of us feel like we don't belong to a place, and I think some of us feel this way because we don't take the time to actively learn a place. But when we study history, when we study ecology, when we study geology in the context of one particular place, and we interact with that place with intention, we shouldn't be too surprised when we start feeling like, you know what, we're just as connected to this landscape as everything else. The trees, the mushrooms, the birds, the salamanders, streams, and rocks. And I'll tell you, based on personal experience, it's a really good feeling when we get there. It's good for us, it's good for everything else that calls a place like this home. Thank you so much for watching this video. I truly appreciate it. I hope you enjoyed it, hope you learned something. If you'd like to stay in touch, please subscribe to the Learn Your Land YouTube channel. Head on over to learnyourland.com, sign up for the email newsletter, and check out my online courses on ecology, tree identification, and mushroom foraging. Thanks again for watching. I will see you on the next video.